Good morning, and welcome to our next presentation. This one is going to be called Parametric Design. What is parametric design? It's not easy to understand, but parametric design means this. For the ladies out there, you may know this. Guys may not know this as much, but for ladies, for either shoes or dresses, they will come up with a size. And they will, for us, for guys as well, shoes. But in essence, you go out and you buy shoes or you buy a dress, you buy it to a particular number, and they have sort of factored in, okay, with that number, how big for a lady's dress, how big are your hips, how long does it need to be, how long are your legs, and they sort of come up with these designs, and you have a dress that's like a 5 or a 7, and you get these dresses, and then as they get up into bigger sizes, sometimes they have half sizes that go a little larger than that, but you have this number that represents the size of a dress, and it's sort of one number that fits. For shoes, you might have that, sometimes there'll be some variation, you might have a width, but if you have a shoe that's a particular size, it will then assume you have a certain length of foot and a certain arch and a certain width, and in general, those fit. Now, there's some odd things. You could have a double E size width, and you'd have to buy that specifically, or a very narrow foot, you could have an A or a B. But in general, if you buy a 10, a size shoe, a very average size 10, it will come with a certain width for your front of your foot, your arches. It'll come a certain length. It'll come with a certain width for your ankle and your size. And all of that will be determined by this one size, 9.5, 10, 10.5, that sort of thing. Okay, that's what parametric design is. So for us, we're going to design one, and then all other designs will be similar to that one design, except all of the sizes and that sort of thing will change based on that design. And like that design, we will have different sizes and different adjustments we'll make. And so that's basically what we're going to talk about when we talk about parametric design. So if you would go to slide 5, you'll see we do this in terms of computers. The other thing, before we get into that too deep, the other thing I wanted to do was talk to you a little bit, for example, Goldilocks. In a story, hopefully you've all heard Goldilocks. Your parents have told you this story, Goldilocks and the Three Bears. And when she got to the house, she always found that the Papa Bear's size was too big, too hard, not quite a right fit for her. And she would find that the mother's size was not quite right, she wouldn't fit. But in Baby Bear, she always found about the same size bed and the same size chair, and it all just fit for her. So she found that when she got into Baby Bear's stuff, it was about the right fit. And so we're going to do the same thing in parametric design, and we're going to pick something that fits for us. And what we're going to do is we're going to design one chair. So let's say we'll take a chair, and I have a chair. I'll bring one forward. So if we took this chair that I'm going to bring forward, this is in my pool room, so this is a particular type of chair, a pool chair. You will notice it has this certain height, right? And it has this certain size cushion. And if I built a smaller chair for a smaller child, we would go down in height. We would also go down in cushion size. We would go down in how wide it is this way, how long it is this way, so the child would fit the appropriate size child. And we can build 8, 10 different chairs, all with the certain size and build and height. And we would change all of those parameters based on what the size of the child were or the adult were, so to speak. And that's what we're going to do, okay? So we're going to design one, and then everything else is going to change around that. So if you look at slide 6, we can build in our program, in Inventor, a certain thing of a certain size, and we could then know that everything would be based appropriately on that one size. And we can do this probably the easiest, and we're going to do that today. We're not going to use Inventor. We are going to use a Excel spreadsheet, and we're going to do some calculations on a particular piece of equipment, and I will show you that here in a little bit. The types of parameters typically are in terms of geometric constraints, parametric constraints, assembly constraints, and we'll get into all of those and show you what those are. right? So for geometric constraints, we're talking about non-numerical constraints, like two lines are parallel or two lines are perpendicular. We have a line that is horizontal, or we have an arc that is concentric with another arc. Those are the kind of things that we're going to talk about, right? And one of the things that you'll see that we will look upon either now or in the future is we have various constraints in Inventor. And if you'll look at slide 9, those are some of the constraints. So we have horizontal or vertical or equal. All of those are various constraints. Concentric, it goes around and they touch. All of those are constraints. And we're going to learn to use those and talk about those parametric constraints. Let me stop the video for just a second.